wait, lots of. Okay. Sorry about that. Can you hear me okay? Nope. And then we're going to try and do this. This is our first live stream, so bear with me just a few minutes. Okay, can you hear me okay? Maybe I'll sit a bit closer. The setup that I had doesn't seem to have worked. If you want, there's a chat which you can open up, and then you can comment if you have any questions or anything. Yeah, so I can see that there are two people, but I can't see. Can you hear me okay? Is that? Let me just have a quick look. Okay. So, without further ado, we've got about 4 minutes to 8. So I'll get started and I'll explain a little bit about this video, why I wanted to do it, and what I hope to talk about this evening. So basically, we have this idea for the EcoVillage, for a homestead, for a farm. For those of you who don't know, we have 7 acres, so about 28,000 square meters, 2.8 hectares of land in Portugal, and we are planning an eco-village around a farm and a homestead that will be self-sustainable as much as possible. And so I've been asked a lot over the past few years about the design, what we want to do, and various notions that people have about going around it. And it's over the years we've refined what we've learned and the different subjects that we've studied about farm design and homestead design. And today we have a sort of general idea of how we want to do it. And when I try to explain that to people, it's a little bit hard sometimes to phrase it concisely, to put it all together. So I was hoping that I could make this video to sort of talk a little bit about our ideas, and then if anyone would like to watch or to listen, they can always check out the video later. So I just want to say before I get started that I've pinned up on the chat, if anybody has any questions about anything I say, or I don't know, something isn't understood, you can always write a question in the chat. Just make sure you type in capital letters so I'll know that it's a question. I'll be able to see it easier, and I hope I'll get around to answering them as quickly as possible. We'll see. So let's start. How we want to design our farm, our homestead. What I'm going to say is not practical examples. So it's not put the dam over here and then put the the garden over there and the house facing. It's more the guidelines and the principles that then you can take to any piece of land or to any project, and with those guidelines design what actually will be. And so what I'm talking about is not the design that we're going to have on our land, but it's the guiding principles that we hope are going to help us when we actually come to design it. So there are 5 main methodologies that we have come to embrace in our search of studying about all these different fields, growing your own food and supplying your own energy and building your own house, etc., etc. And there are 5 main methodologies that we have sort of selected. And it's important to say that a lot of these methodologies overlap. Some of them talk about the same things. Some of them are included in one another. And so it's not a clear-cut state of this is, permaculture, for example, and this is keyline farming, and they're 2 separate things. There is overlap between them, but each of these methods has been refined and designed individually, either by the specific people who invented it or by more and more people who joined. And so I want to divide, give that sort of array of the different things, the different methods that we are embracing. And so we're going to order them. I'll list them from most well-known, I should say, to the least well-known. And so the first one is permaculture, which I'm assuming almost everyone has heard about today at least. The second one is food forests, which I'll explain more about as we go into. The third one is earthships. The fourth method is called natural farming, and it's mainly recognized as Masanobu Fukuoka's work. He was a Japanese agronomist, and that's the name that he gave to the method. And finally, keyline farming, which was invented by P.A. Yeomans, who was an Australian. He was a farmer into grazing. And so I'll talk a little bit about each of those methods and why we decided to embrace those specifically. So the first is permaculture. Now, if you don't know, permaculture comes from the combination of two words, permanent agriculture. And it's a really shift in the way that we start looking at growing food specifically, and in general, all of our agricultural practices. And so the methods that were around before permaculture were sort of very hyper-productive, a very, very large emphasis on the efficiency and the quick return on investments, basically. And with permanent agriculture, with permaculture, the emphasis is not about the quick return, it's about long-term planning, and with that long-term sustainability. And so permaculture began in the 1970s, 80s. It was brought about by two people, Bill Mollison and, oh gosh, I've forgotten his name, not Sepp Holzer. I'll put a link underneath. I can't remember the student's name. David Holmgren. Sorry, Bill Mollison and David Holmgren. Bill Mollison was David's professor, and together they sort of co-authored this idea about permanent agriculture. Since then, it's obviously grown to be a huge global movement. Most people have somehow heard either about permaculture design courses or community gardens, or there's lots and lots of different fields that permaculture has sort of sprung into. And in all honesty, I think everything that I'm talking about tonight, maybe except for the earthships, permaculture discusses in one way or another or mentions. So it is the largest system of the five and the most encapsulating. And because of that, I'm going to focus specifically on the general view of it, because if you start getting into specifics, there's just no end to it. So this view of permanent agriculture is a real shift in the way we can actually perceive the world. We've seen over the past few decades or even longer that there's been a sort of narrowing of attention, of the depth of our thought, of the length of time with which we plan. And it's this sort of shortening of all of those things that's led to a much faster pace. And we can see whether it's technological advancements or the changes that are happening in the world are happening much faster. But at the same time, there's a certain price that we pay whenever we lean in one direction. And so I feel that the permaculture, the shift in consciousness that it's trying to bring forward is really about much more long-term. And so the changes that happen in permaculture usually happen slower. If you compare coming in and with all the heavy machinery and fertilizers, raising, rows of vegetables in a monoculture system, it would probably go much, much quicker. You could set it up much quicker because of the machinery and because it's designed for machines to work it. And with the fertilizers and all these things, it would probably be a quicker first yield to begin with. The thing is that over time, and this is what we've seen, there's a decrease. There's a decrease in fertility, and also in because of that, in the efficiency, in the amount of energy you have to input in order to get the same result. And so with permaculture, there's this slowing down. You do things more slowly, the changes happen more gradually, but because of that slowness, in a way, the stability is much, much greater. And so you grow a system that over 5 years has matured, instead of it being 1 or 2 growth seasons. But now after it's matured, it's much, much more stable. And that means it can also handle a lot of changes in the climate, in the environment, and be able to survive. Whereas we see that a lot of the times with monoculture, when the land is grown with one crop year after year after year, and the system itself isn't increasing in fertility and isn't growing, it's staying sort of the same. Because of that, it's actually losing its stability. And if it's attacked by pests or a virus, it can be very, very susceptible. I won't go into all of the examples in history, but if you want to find out more, there's a lot of information. So permaculture is really teaching us to have this long distance view. What's going on in the world today, and what is the world going to look like in 10 years, in 20 years, in 50 years? And even if we don't know how it's going to look, what can we do to be the most resilient and the most stable system that can withhold these changes that can happen to our climate and in our environments? And so I think I'll move on to the second subject, because permaculture, again, I'll say if you want to learn any more, you can always look onto it. The second concept is called food forests, and it's actually made famous from permaculture probably, but it's such an important concept that I wanted to talk specifically about that. So for those of you who don't know, a food forest is a way to design a garden or some kind of growing system that attempts to emulate, to copy the system that a forest has. And so there's this natural system, this vast ecosystem in nature, which we call forest, which comprises of hundreds, thousands, and millions, I don't know how many, of species and different organisms. And the thing about it is that it's completely unmanaged. So it gets all its own water from the rain and from its environment. It gets all the nourishment and the crops that sustain it from the forest itself. So it basically produces and manages its own waste, produces everything that it needs on site. And so people sort of looked at this and said, why don't we try and design that into our system? And so let's make a garden that, instead of us having to go and turn on the water and fertilize and make sure the pests don't come and put all this extra effort in, let's design a system like the forest that will manage itself, and that over time will require less and less input of work instead of more and more. And so the food forest actually encapsulates in it this very interesting concept, which is, it's called biomimicry. Biomimicry, bio being life and mimicry meaning copy, means to look at a natural system that has evolved without man, as it were, and try and copy the design and the structure and use that for our own benefit. And so there are many, many examples. I won't go into any of them. There's some very interesting experiments that were done with fungi, both in designing city roads and in clearing mazes, and very interesting subjects. I might put a link underneath about that. But food forests are basically one example of biomimicry, where we try and see this system of a forest that's very robust and resilient and self-managed, self-sustainable, and try and copy that design in our own. And so if we're talking about planting a food forest inside our homestead, which is a big part of what we want to do, the food forest itself is going to be part of a larger system of the farm. And so food forests can be very, very small. There are food forest gardens that can be literally in your backyard of 20 or 30 square meters, but you still try and utilize those same design principles as you would do on a larger scale. And so in our design, we're going to have food forests that will be integrated into part of the general design, but then in that specific food forest, you want to design it to be different layers. And so the height of each plant basically gives you another layer with which you can work. And each layer has different moisture, different plants that grow there, different amounts of sunlight, et cetera, et cetera. And you try to design it so that the different plants that you have actually fruit all year round. And so instead of having sort of an on season and then an off season where in the winter nothing grows, you try and stagger the fruiting periods of different trees and have enough of a diverse different species so that you will have food throughout the year. The last small thing that I'll say about food forests, which is a very important concept, when you start planting a food forest, you start, well, this is actually what Jeff Lawton, who's a big permaculturist, says, and I very much like his work. He has a YouTube channel as well with great videos. I'll put a link up afterwards for that. He says that when you plant a food forest, you want to plant with 10% your productive crops, your fruit crops, and 90% sustaining crops, as it were. And so the sustaining crops are basically all crops that you're going to put back into the earth. There's a method called chop and drop, where you don't pull it out with the roots, you don't kill off the plant, but you cut it down right at the bottom, and then you let that decay and go back to the ground as nourishment for the earth and all the others. And the root system that's inside actually decays in the ground and also releases. And a very important species in this is a nitrogen fixing species. Nitrogen fixing means it can actually take nitrogen from the air, and through bacteria that grow on the root system, actually bring that nitrogen back into the earth. And so if you have a land that's lacking in nourishment and lacking in nitrogen, you want to plant a lot of nitrogen fixers, and then also chop and drop, bring those back into the ground. So that's a little bit about food forests and the design principles that we want to follow. The next method is earthship. And the earthship is sort of, I think, the most isolated of these five in terms of it really is a self-sustained group, as it were. And I just want to say that when I was studying and came across all of these amazing people with amazing ideas, it sort of often made me a little sad, and I didn't understand why there wasn't more cooperation between these people, because it seemed that the goal was to help our planet, to help humanity, to solve problems that we're faced with. And the solutions were all incredible, and they weren't mutually exclusive. They could both be and sort of even complement each other. But I never heard the earthships talk about the permaculture movement that much when I sort of saw it. It's very self-contained. If you're earthship, then you're earthship, and that's what you know, and that's what you do. And the same thing with permaculture a lot. And when I'd come and talk about earthships with permaculture people, they would often say, yeah, that's fine, but, you know, permaculture has house designs as well, and there's cob buildings, and there's all these different, you know, permaculture talks a lot about building a house. So maybe this would be the time to talk a little bit about what the earthship is and why we decided to include it. And this is to say that we want to use all of these methods and whatever we can, really, that will be useful and helpful. And so the idea of the earthship is a rather large one. There's this, the architect who invented it is called Mike Reynolds, and he first came up with the idea 40, maybe 50 years ago now, and has been refining it and improving it ever since, and they're still working today. There's there's a center in Taos, New Mexico, where they have an earthship community, where they have a research and a development center, and they're constantly improving, constantly checking themselves, constantly updating the technology. So it's very interesting work if you want to see. But his idea was he wanted to design the perfect home. And so he sort of looked at all of these different elements, what a person needs in the house, what are the materials that are cheap and available, and what problems that we face in terms of climate. And he tried to answer as many of those problems. And I think he did a really amazing job. So he designed this house, which has so much thought and really ingenuity into the design, into the structure, the shape, the building materials. And so I'll list just a few, but I won't be able to do it justice in the short amount of time that I want for this video. So the building material that's mostly used is tires, which is the famous thing that most people have seen, packed with sand. And the thing is that you take the tires and you hammer them in with a sledgehammer until they really pack tightly into the tires. The tires are obviously designed to withhold large amounts of pressure, so it's perfect for that. And what happens then is you build a wall with these tires packed, and that wall is buried and covered with earth, and the earth berm goes for a large way out. So you have this huge mass of earth with these tires structured. The tires are actually connected with, they're cemented with a layer before they're buried under the earth. And so what this does is it does a few things. First of all, we have a problem of tires, we have a problem of rubber, and this rubber releases toxins into the atmosphere once it's degraded by the sun. So all of the huge piles of tires that we have around the world are actually releasing gases into the atmosphere and raising the CO2. The way to combat that, or one of the ways, is to bury those tires underground so that they're not exposed to the sun, which is exactly what the Earthship does. If you bury them under the sun, there's close to no degradation over time. It's a very, very stable material. And so here you've got a building material that, as long as it's buried, can last, we don't know how long, but certainly won't degrade over time. The second thing about it is, because you've got one sort of structure, very, very solid structure that's connected, it's not foundations, which the way foundations work, they concentrate the mass and the weight on specific points, and those points are sort of load bearing. And so in the event of anything like an earthquake, which will put force on that, pressure on that, it'll be more likely to break. And concrete is actually a material that can crack, as we know. When you have these earth walls, when what happens in an earthquake is that, because it's all one solid piece and it's not one point, it can actually ripple out this energy from the earthquake and allow it to diffuse much more gently throughout the structure. And another reason it can do this is because the sand itself is much more inclined to sort of vibrate and not as brittle as the concrete. And so it's much, much stronger and safer in the event of earthquakes. It's fireproof. There's a lot of different things about this structure and the sand structure inside the tires that makes it very, very useful. Basically, it has this ability to passively cool and heat. This has to do with the design of the windows and the angle as well. But in the winter, when the sun is low, it heats up. It goes straight into the back of the house and sort of heats up this huge, massive earth berm. And so when the sun goes down, the temperature shifts, and the temperature inside the house drops to lower the temperature of the heat stored in the walls. And at that point, that temperature starts sucking the heat automatically out of the walls because of convection. And I haven't actually experienced this specifically, but people in cold climates in the Earthship say it's like the heating turns on automatically. At a certain time, when the temperature drops, the heat starts flooding back from the walls and actually heats it up. Mike Reynolds says that he has a fireplace in the Earthship, and he lights it once a year at Christmas because it's like a fun thing for the kids. But a well-designed Earthship that works properly doesn't need heating or cooling. Electrically or gas or any other way. It uses natural passive convection and the difference in temperatures to do that automatically. There's so much more I could say about the Earthship, but I'm going to stop there because it's I don't want it to be too long. But if you're interested, please go and check it out. If you have any questions, you're more than welcome to ask. I'd be happy to talk to you about it. It's really fascinating. Okay, next subject, natural farming by Masanobu Fukuoka. Now, the natural farming was a method that he invented or discovered, as it were, around the same time, around the 70s, I think, 60s or 70s, don't quote me on that. But it's an interesting method because there's a lot of overlap, again, with permaculture and with food forest and with a lot of different methods that I've talked about. But nonetheless, I think he deserves specific recognition. And the reason is he's a very interesting person because he was an agronomist, and agronomists were raised on the Industrial Revolution and monoculture, and really this was before there was any talk about permaculture or anything like that. And so his story was that he was walking home one day and he saw rice, wild rice growing on the side of the road. And he looked at the rice and he was surprised to see that it was very healthy. And he looked at the other side of the road, and there in the fields, there were Japanese workers who were working the fields and tilling them and spending hours and hours. And here, by the side of the road, with no watering, no work, this rice was growing just as good, if not better, just as well, if not better than the rice that was growing in the fields. And this led Masanobu on to his sort of research and discovery, where he sort of he approached it in a very specific way. He said, let me look at the different things that humans do in order to grow plants and to grow crops, and see what of that isn't necessary and what of that is actually detrimental, is actually bad. And so he began his study on his farm. He had some land in Japan, and he sort of started by growing the crops and seeing what was happening. And he slowly realized that really and truly, everything that we do as farmers who are trying to grow, nature already does. So whether it's tilling the land, which means sort of plowing it and aerating the earth and aerating the soil so that water and air can come in, there's a vast array of organisms who are doing that. Ants and nematodes, I won't go over them because I don't know enough, but all of the animals that burrow underground are doing exactly what we try to do when we plow the land. The only difference is that when we plow the land, we kill most of the topsoil. We do enormous damage to the root systems and to the biosphere that's living in these topsoils and subsoils. When the organisms do them themselves, they safeguard the life that's growing underneath, and so they do a much better job at increasing the fertility. Two very big subjects that Masanobu mentions again and again, because back then it was a lot less well known, are the introduction of chemicals, both as fertilizers and as biocides, pesticides, fungicides. And he was very, very adamant, and we are as well, and this is pretty easy, that we don't want to use any chemicals because there's no need. These chemicals that we need to grow, whether it's nitrogen or phosphate, grow naturally. And if you have the biosphere to sustain it, as Masanobu discovered, there's no need to add any fertilizer. And unlike when you add fertilizer, you have to keep adding every year. When you're not adding it and when you're allowing the organisms to do it, the fertility actually increases over time. And so I think I'll leave it with that. Masanobu Fukuoka is a very interesting man. He's written a few books. His first book, The One Straw Revolution, talks all about natural farming. And if you want to read a little bit about it, it's a fascinating book. It's not just a practical guide to how to. It's a really philosophical. He's actually a very philosophical man, and he practices his. I think it's Taoism, if I'm not mistaken. Maybe it's Zen Buddhism, but he practices his philosophy in his farm. So very interesting character. Okay, so we've reached the final method. And this is probably my personal favorite. This is sort of the one that I'm inclined to, and it's, I think, the least well known. When I've talked to people about it, some people have heard about it. Most people don't know too much, and people who aren't interested in these subjects have never ever heard about it. And the method is called keyline farming. It was invented by P.A. Yeomans. He was also in Australia, and actually him and Bill Mollison, one of the co-creators of permaculture, were friends and discussed things a lot, and actually met during their time together. Obviously, they were both in similar fields. I didn't actually know this until recently. I just discovered it when Bill Mollison mentioned it. And so permaculture discusses keyline and mentions keyline. They always say it's a very complex system. You don't have to learn all of it. All you have to know is, and then sort of summarize it very small, which is fine. And I completely understand, but the keyline method for me is something that's worth talking about specifically because of the way they think about it. So again, this is not to say that permaculture doesn't recognize any of this or, has nothing to say about it, but just that I think P.A. Yeomans deserves his own mentioning. He was a genius. He was actually a mine engineer. And so he designed and engineered mines. And it was with this work that he started to study and understand basically water passage. And so in designing mines, the passage of water is very, very crucial for the stability of mine. You have to know how to move, where it comes from, etc. And that sort of started him on his way. A few years later, he inherited, or his wife inherited, a vast amount of land. I can't remember how much, but thousands of hectares. I mean, something absolutely enormous. And with no experience in agriculture, Pierre Yeomans was sort of called to, I don't know, leave his job and came to sort of manage this farm, this gigantic piece of land, with, I think, no experience from what I know. And with such a big land, he was inclined towards grazing, so raising cattle. And he became, the land that he inherited was very, very poor quality. Not fertile, you know, shale and like very, very sandy, very, very dry climate, Australia, many months of drought. And he was faced with a very, very tough situation to begin with. And I think that's probably what caused him to invent this ingenious method. And the first thing that he did was simply observe. He would go on long walks in the land when it was raining and just walk for hours, just walk this vast area and observe and watch. And it was through this that he started to see the natural path that the water was taking. The rainwaters would come and they would sort of, there's this pattern that you can see where it goes, why it goes there, where it pools, how quickly it flows, all these different things. And he began to study this, and he discovered this term, which he called the key point. And I won't go too much into the geometry, which is exactly what permaculturists say, but it's a little bit confusing. It takes a little bit to understand, to see it. It's a very, very visual thing, and to try and explain it without seeing a valley, at least the drawing, is a little bit harder. But I'll explain the basic principle, which is, if you imagine a sort of valley. So we have a valley, which is the dip that goes down, and we have the ridge next to it. I'm going to do it like this because that'll be easier. So we have the ridge, which is the top part, and then the valley, which is the bottom part, and then another ridge after that, and then another valley after that. And that's the way it goes with all the water that leads from the higher place down into these much, much bigger sort of riverbeds, and that's where rivers start. And so he saw that on that inclination downwards, there was this point where the angle of the drop would change, would temper much, much more, and then it would go down again. And so the point at which it tempers, he would call the key point. And so if you take that key point and you draw it out across the land, across the ridges and the valleys, you get this line, which is what he called key line. And he would use this line to do two things. Well, more than two, but one of the things was the valley, the shallow part, is obviously the place that gets much more wet when the rain comes, and the ridge is the drier part. And so he wanted to understand or figure a way to take the water from the wettest part to the driest part. And using this key line, which stays on contour, which means it stays at the same height, doesn't go down or up, so the water that collects there starts flowing naturally, can actually go from the valley, the key line in the valley, over to the key line on the ridge. And so instead of having these sort of dips where there's lots and lots of moisture in the valleys, and then the ridges, which are much higher and it's much harder to farm it more evenly, he was using these lines to carry water across on contour, across on the same height, and water the land more evenly throughout. And so from this basic principle, he developed a vast network of dams, and he called them, I can't remember what he calls them, but basically they were channels for channeling the water. In permaculture, you'd probably call it a swale or talk about swales, but what he did was he'd take all of the water that came to the highest point on the land in the rainfall and store as much of it in a very, very large dam at the high point. And then once that filled, he would have a spillway, so that when it came up to a certain height, there'd be like a hole. He'd actually have a channel, and then that channel would carry the water, and that would go on contour through the key line, watering the land underneath, and eventually get to another dam, which would store more water and would store water from around there as well. And that way he would hold water in vast amounts throughout the land and could water in the months of when there was no rain, without any pumps, without any energy, basically, just gravity fed all the way through. And what he said was that he had enough water stored in Australia, don't forget, for 2 years of drought. When I heard this figure, and people that I tell this figure to, that's unbelievable. The heat and the amount of evaporation. Besides, I mean, the pictures that I've seen, there were no trees shading the dams. So the dams, I can only imagine, have a large amount of evaporating throughout the summer months, and to have enough water to water large amounts of land in the dry season in Australia is really incredible. Okay, so I think that's basically what I wanted to talk about. The way, if I could just sum up, that we want to use these methods, it's really all about different perspectives and how you look at things. Specifically when it comes to farming, if you look at the water and you think about how it goes from the highest point to the lowest point and what you wanted to do at that point, or if you think about the house and you think, what do I need the house to do for me? How can I design it so that it'll do that naturally? Or if you're growing crops and you want to grow different species, you can say, what supporting species around do I need to grow so that it will grow more easily without me having to invest more energy? These different ways of thinking about it, I think, are very, very important in a new design for agriculture, where the focus is on a system that will grow more and more robust over time with less and less energy needed to actually input. And so we'll see in the next few years, as the farm develops and the homestead gets built, how much of what I'm saying is actually going to happen. But I have every faith that this is work that's been done by very talented people for a long time. It's been tried and tested all over the world in different climates. And for any of you who are thinking, whether it's a backyard, a small garden, indoor plants, or even, you know, your next homestead, I would encourage you to research these different methods, because they've been very, very helpful for us on our journey. So that's it. Thank you very much for joining. I can see just that, Carl, I just want to say thank you so much for your comments. And if anybody has any questions before we wrap this up, feel free to write them in the chat now. Thank you very, very much for joining and for tuning in, for spending all this time with me. I do apologize for the technical difficulties. I think this is the fifth or sixth time that I'm trying a live stream, and every single time it's had technical difficulties. So I'm glad we at least managed to get it running in the end. Thank you for your patience. Hopefully next time I'll have my better camera connected and it'll be a much better setup. So the first of many. Okay, thanks very much for joining. Have a wonderful evening, and don't forget to subscribe, like, and comment. Bye.